On July 1st this year, NASA's Survey telescope captured this image. That's what you're looking at. This thing is marked by the yellow arrow in the middle. It is approaching the Earth at a speed of 61 kilometers per second. That many people guess it could be a meteorite or a comet. But a professor of astrophysics at Harvard, Avi Loeb, he said this thing. It could be an alien nuclear-powered spacecraft. And who is this guy? When Momo came, this is the first time he has proposed. Momo was made by aliens, and he became famous. But it turned out that nothing happened. Momo is leaving soon. It's over. This time he stood up again and said, this thing could be an alien spacecraft. As soon as he came to this conclusion, it became very popular very quickly. Everyone was stunned, because at his current speed, it will arrive on Earth in December. He will be closest to the Sun on October 29th. Originally at this time, this is the best time for us to observe him from Earth. But he happened to be at this moment. We'll go around the back of the Sun. We can't observe it. It's like he's avoiding us on purpose. So Loeb said, could he have come prepared? Was his route carefully designed? When he goes around the back of the Sun, is it possible to attack us? Even when he was on August 22nd, another blog post, he said this thing could also be made of antimatter. Such exaggerated speed and eccentricity. What if he's made of antimatter? Then once he touches us, the energy he released in an instant was enough to destroy the Earth. What about the above point of view? It was this Harvard professor, Avi Loeb hypothesis. So, that's hypothetical. It doesn't matter if you're bold. The problem is that this professor has spent the past 8 years frequently attribute some phenomena to aliens. Instead, it lowered his reputation in the field. So think about this. If his target is really the Earth, then he can fly directly towards Earth. And on his current path, even at its closest approach to the Earth, both still have 1.8 astronomical units. The chances of an impact on Earth are near zero. Instead, he is closer to Mars. Then he came to the solar system from so far away. Is it to see Mars? But Mars, we all know, it's a very inhospitable planet. Sure, that's it. If he really came to attack the Earth, he doesn't have to go far. And his trajectory aside. Loeb said at the beginning, at his speed of over 60 kilometers per second, we can't intercept it at all. I can't because it's too fast. But a few days later, he sent another paper saying, it is recommended that the Juno fly over to intercept him. But the problem is that Juno doesn't have enough fuel, and the main engine has also been scrapped. It's impossible to intercept Atlas. So a lot of his claims are contradictory. Certainly, I'm not arguing against the alien hypothesis. Or suppose, I also believe that aliens must exist. Even if Hawking keeps reminding, let's not make contact with aliens, including the dark forest hypothesis. The universe is like a dark forest. Every civilization is a hunter lurking in the forest. No one knows if there are any enemies in the forest. No one can be sure if the other person is friendly. So once you expose yourself, it may be preemptively destroyed by the enemy. Even so, I also believe that humans should take the initiative to explore. Although the chances of finding aliens are slim, but potentially, the payoff is huge. So what is this thing? From the current Hubble telescope and the Webb telescope observations, it can be concluded that it is an interstellar comet. It is the third interstellar object we have discovered, also called interstellar visitor. The first one is Momo. The second one is a comet called Borisov, we said before. And then this one is called Atlas. You can rest assured, he poses no threat to Earth at all. However, his speed and route are indeed exaggerated. We trace his path, discover his origin, perhaps older than the age of our solar system. So coming from so far, drifting through the universe for billions of years, he can accumulate such a high inertial velocity. More than 60 kilometers per second. We know, the man-made satellite we launched from the Earth, as long as the speed can reach 7.9 kilometers per second. That's the first speed. Then he can orbit the Earth. If it were faster, it can reach a second cosmic speed of 11.2 kilometers per second. That's the Earth's escape velocity. Then he can fly out of the control of the Earth's attractive forces. Let's say we want to go to the Moon or to Mars. Must exceed the second cosmic velocity. If you hurry up, it can reach 16.7 kilometers per second. The third cosmic velocity. Then he can fly out of the attractive forces of the solar system. So far, 2 probes have flown out of the heliosphere. Voyager 1 and 2. Now the fastest Voyager 1. It's traveling at about 17 kilometers per second. The speed of Atlas is over 60 kilometers per second, several times that of Voyager 1. Look at this picture again. It is the route when Iomo came to the solar system. It's almost vertical, then a sharp turn back. And then this is the second Borisov, husband's route. He came in, he flew through the solar system, he flew away. What about this Atlas this time? His route is very close to a straight line. And what exactly is that? When we say eccentricity is equal to the orbit is a perfect circle. That's like Earth. The eccentricity of the planet Mars is greater than 0, less than 1. If it is a celestial body with an eccentricity greater than 1, the attractive force of the Sun won't hold him. For example, the eccentricity of a Momo is 1.2. Borisov's eccentricity is 3.36. The eccentricity of Atlas is 6.3. He's the largest. He opens his orbits at an exaggerated angle, close to 180 degrees, and he came in with the ecliptic plane, then it flew out against the Mars. Except for Atlas. Recently, there is another thing that has been fired more severely. NASA has discovered life on Mars. Certainly, it's not the kind of life that people think is alive and kicking, but billions of years ago, microorganisms that may exist on Mars. Where was it found on Mars? That's the rock you see here. I just said that in the last Mars video. It's the Perseverance River, in Yesara Crater, found in a dry riverbed. NASA named it Chejava Falls, the name of a waterfall from the Grand Canyon in the United States. Because the surface of this rock, there are many round spots of this deep and light color. It looks like a leopard, so it is also called leopard print stone. After Perseverance approaches, I used the instrument to detect the composition of these spots. As a result, ferrite and pyrrhotite were detected, and organic carbon. Where do these minerals and organic matter come from? Scientists initially speculated it may be caused by a high-temperature reaction. It is also possible that it was formed in a strong acid environment. However, Perseverance further analyzed, later discovered, this rock formed at a very cold temperature, and it doesn't seem to form in a strong acid environment either. So after ruling out these naturally occurring factors, the remaining plausible explanation is there might have been life here. You know, carbon, hydrogen, oxygen, nitrogen, these elements. It's the building blocks of life. On Earth, these minerals and organic matter, usually after the life activities of microorganisms. To put it bluntly, it's like the feces of the microbes after they eat something. It's what they metabolize. And this time, they also appeared on the same rock, not everywhere on Mars. So let the scientists doubt, were there ever microbes lived on this rock? So somebody might have a question. Since it is the excrement of microorganisms, is there any chance we could extract DNA from it? This shouldn't be possible. Because you think about billions of years, even the rocks on the Earth, DNA doesn't last that long, let alone Mars. Mars, without Earth's magnetic field and atmospheric protection. Surface, long-term exposure to cosmic radiation and ultraviolet light. All the genetic material has also been destroyed for you. But if DNA could be found on Mars, that's awesome. Maybe we will know the origin of life on Earth. We can compare it to the DNA of life on Earth. Is there anything in common? To test a scientific hypothesis, it's called panspermia. Panspermia holds that life did not originate on Earth. They exist throughout the universe, through the carrier of meteorites or comets, spread through the universe, and eventually some life was brought to Earth. In this suitable environment, gradually this evolved. This hypothesis may sound ridiculous, but it's not groundless. We're actually here on Earth, found a lot of meteorites from Mars. These meteorites were originally formed on Mars, but because Mars received an asteroid, or a comet impact, was thrown into space. After millions of years of drift, it landed on Earth. Of all the meteorites in the world, only 277 are classified as Martian meteorites, less than 0.5%. These meteorites are very precious. Because they are all natural Martian samples, we can study it without going to Mars. So how do we know? Are these meteorites from Mars? In fact, these meteorites contain some gas. Scientists analyzed the gases in these meteorites, found are in helium, neon and argon, and carbon dioxide in proportion to these gaseous elements. It's almost identical to the atmosphere of Mars. But with the Earth and the Moon, asteroid gases are different. So this is the strongest evidence that they are from Mars. So according to Fan Zhonglun, as long as there is even one tenacious microbe, catch this meteorite. For example, the waterworms we usually hear about. A microorganism that is difficult to kill on Earth. That would change our understanding of the origin of life. So could waterworms have come from Mars?